I think it's only through this type of collaboration that we can make AI-directed materials design a reality.
Hello everyone, I'm Shijing. I'm an associate professor here at the University of Cambridge. I'm based at the Department of Material Science and Metallurgy.
Hi, I'm Aron Walsh. I'm a professor of materials design at Imperial College London, and I'm Chief Scientific Officer at CUSP AI. So my background originally was in computational chemistry, and I now specialize in AI for material science. The thinking behind our project, alignment of generative AI for materials discovery
By experimental feedback.
Came from my side from work that was starting in London. So we were working on open source models for generative AI for crystals. So the idea of using these techniques from the artificial intelligence community to explore chemical space in different ways. We had good successes. We have an open source platform called Chameleon that can generate crystals with target properties, but we needed a way to test those models more efficiently. And that's where Shijing came in.
Yeah, so for my group, we've been working on semiconductors, especially the perovskite semiconductors for the past decades. During these 10 years of working on process semiconductors, we managed to build our expertise together with very efficient ways to automate the synthesis and characterization of these materials.
So our current models work really well for perfect crystals. So the idea of atoms frozen in space, which can be quite different from some of the realities that you face experimentally with the effects of temperature, with crystal disorder. So the challenge is that we need to have data in order to train to update our models for dealing with those experimental complexities. So the approach we're going to follow is to link closely with the work in Cambridge. So we'll get data and feedback from the automated lab systems that we can use to adapt our generative models to deal with these processing parameters that are relevant for real materials.
So experimentally, we're going to go through a series of steps with increasing complexity. We will first set up the automated experimental workflow, which allows us to benchmark our throughput, our speed, and our experimental robustness of generating the experimental data needed for the AI models. We're going to start with a relatively simple chemical space of exploration, and we'll move forward to increase the complexity towards the material discovery in a more complicated chemical and structural space of semiconductors.
So in this project, there are, I would say, three main participants. There will be one postdoc based in London focused on generative AI, one based in Cambridge focused on setting up and controlling the lab automation. And then, of course, we have the robot itself, Mara.
Yeah, Mara.
And so Mara will be doing a lot of the work. So actually doing the materials processing, the characterization, and feeding back in to our models.
In Cambridge, we are building a new automated materials discovery lab. So we have our Mara robotic liquid handling platform, and we look forward to working with new postdoctoral researchers to join our team on this project to work together with the robotic synthesis and the characterization platforms for this project.
So I guess one thing I would say, I really think AI and automation lies at the future of materials science. I think there have been really great successes in the past of discovering systems by chance, but here we can use the data of what we know. We can take rules from chemistry and physics, and we can try to identify new candidates as efficiently as possible. And I think it's only in this type of partnership between modeling, AI, and automation experiment, having a feedback loop, where we can really make some big contributions. So AI for materials science is moving forward at an incredibly rapid pace. So it's actually hard these days to write a grant application that's still relevant by the time the project's funded. So that's why the streamlined approach by Alchemy was really appreciated. So I could work with Shijing. We put together a research-focused application that went through the process in several months instead of waiting over a year to actually start this project.
One thing that really excites me about this project is we are working towards this ultimate goal of closing the gap between what we can predict in terms of the new materials, properties, to what we can actually make in the lab.